In this next demonstration, we're going to focus on going from a 2D drawing into a 3D model. Whether this is legacy data within my company, or maybe a customer or a vendor provided me a drawing, what I need to do is create a 3D model from it. And we have some tools inside of Solid Edge that allow you to do that very easily. One of those being Create 3D. So in the Create 3D dialog, you'll notice that it'll specify or allow you to specify which template you want to work in, whether it's a part or a sheet metal, or maybe you want to bring in some assembly layouts very quickly into an assembly drawing or assembly template. In the next window, you'll see what scale we want to work in, and then also whether or not we want to work in first or third angle projection, and then what types of information or what types of dimensions do we want to bring in with the 2D geometry. I'm going to zoom in to the front view, and I'm going to select both the geometry as well as the dimensions, and I'll do that for the other views as well. Just with the window select, I can do that for all three views that I have. If I wanted to include the fourth, I could do that also. But the three views are going to allow me to get all the information that I need. What you'll notice is once you hit that Finish button, Solid Edge is going to automatically bring in all the views as well as all the dimensions, and it also lines up those views relative to each other. You'll notice that I selected a part template as opposed to sheet metal. I could have selected either one, and I purposely chose part for this example because I want to show you some other benefits that you have or some other options you have when you're going from part into sheet metal. So in order to start creating the solid model for this example, what I'm going to do is just start grabbing the different regions that are associated with that front model view that we saw in the drawing. And I'll rotate over to the other side and grab the remaining regions. And once those are selected, you'll notice that I can select the steering wheel tool and essentially create my third dimension or my depth based off of that top drawing view. As I flip it over to the right side view, this time I'm going to window select all of these slots. These slots actually exist on both sides of the part. I'm just going to window select and very quickly just drag those through the part. And now I've got slots on both sides of the model. As I zoom in a little bit, you'll also notice that we have these holes along both sides of the part on these top flanges. And very similar to what we just did with the slots, I can very quickly just select each of those holes, and I'm going to do that on both sides. Just again, window selection, and I'll rotate the model up and zoom in just a little bit, and we'll go ahead and specify that we just want to blast those holes through that top face on both sides of the model. The last feature for this part is these rectangular cutouts. Now you'll notice that these sketches, or this top sketch at least, is basically up here on the top as opposed to the bottom, and that's okay. What you'll notice is that when I select these two regions, because those are floating up in space, when I go to start creating geometry, it assumes I want to add geometry, but I actually want to remove, and just by hitting the space bar, it'll toggle it from protrusion to cutout very easily for me. If you've noticed, the dimensions have gone from that orange color to a blue color, and essentially what we've done is, let me go ahead and turn off the sketches. I really don't need those anymore because now I have the 3D model. All of those dimensions from the drawing have now attached themselves to the newly created model. So what does that do for us? Well, what you'll notice is, as I select a dimension, if I need to modify the part, I can do that. So as I either shorten up the part or maybe make it a little bit wider, notice how I can dynamically change the model from here. As I'm doing that, you'll notice that the flanges are also getting longer on the top. Same thing, the holes are not moving with the flange, and that's okay because you can still add that intelligence in back to the model. So how would I do that? Well, on the drawing I had a length for the flange, and if I want to maintain that, I'll just go ahead and select the dimension, and I can easily lock that value. That's going to maintain the length of that flange. Same thing, those holes weren't moving before. So what I can do is I can select that dimension for the hole. What you'll notice is it's more of a purplish color as opposed to blue. And that's because in the 2D drawing it was dimensioned to the midpoint of the flange as opposed to the hole, and that's actually what the dimension is referencing. So one of the options you have too is you can actually hold down your Alt key on the keyboard and reselect what your dimension is to. And this time I'm going to grab the center point of the hole, and now this dimension is referencing the hole as opposed to the midpoint of the flange. And I want to go ahead and keep that locked as well. I want to maintain that value from the edge of the flange. And so what you'll notice now is as I make this part a little bit wider, the flanges are going to stay that same length as well as the hole locations. So it's very easy to dynamically start modifying the part if I need to. I have a fully parameterized model from 2D into 3D in just a matter of minutes. And then just one last thing, as I mentioned, we started off in a part modeling environment, but this is actually a sheet metal part. So what I want to show you is you can actually take what we created as protrusions and cutouts, and I can do a transform to sheet metal. And what Solid Edge will do for us automatically is it will take those protrusions and cutouts and automatically convert them to tabs and flanges. If I wanted to as well, if I wanted to take this a step further, I could also utilize the Recognize Holes option. Solid Edge would find each of those holes, and if I needed to change any of those parameters, I could do that, but I'm just going to leave them as they are. And what's nice about this is now we have parameterized holes as well. So again, a lot of flexibility, a lot of power in going from 2D to 3D, and I hope you enjoyed this demonstration. Actually, one more thing I wanted to wrap up with is obviously with sheet metal components, a lot of times what's critical is having that flat pattern. So I want to go ahead and turn off the dimensions just for a minute, but obviously now that we've converted this part to sheet metal, now we have the ability to come in and say I want to generate a flat pattern of this part. And very quickly you'll notice it takes us from our formed sheet metal part into our flat pattern, and now we have that for manufacturing purposes. So again, hopefully you enjoyed this demonstration.